Hi, let's start chapter number 5. The chapter is chemical calculation. Our key learning objectives will be to understand the mole as a fundamental unit in chemistry, calculate molecular and empirical formula, determine relationship between moles, mass and particle numbers, analyze chemical reactions and their quantitative aspects. Alright, so let's start with stoichiometry. It's a chemical accounting. Fundamental concepts here is mole, which is a standard amount of substance containing a known number of particles. It is important, so it's important to learn it. Then atoms are neither created nor destroyed in chemical reactions and tracks chemical transformation at atomic level. So let's talk about green chemistry principles. Key considerations here are reduce hazardous substance involvement, emphasize environmental safety, maximize atom economy. Atom economy is measures percentage of reactant atoms ending in desired product. High atom economy indicates sustainable development, economic efficiency, and minimal waste production. Now let's talk about limiting reactants. Now identification method is first calculate moles of each reactant. Then divide moles by coefficient to balance equation. And then smallest number will indicate the limiting reactant. Next we have factors affecting yield, incomplete reactions, weighing errors, material loss during transfer, and separation challenges. Some key terminologies that you must learn includes number 1 mole. The definition is a standard quantity of substance and it is significant because it tells us about fundamental chemical measurement. Stoichiometry is a quantitative relationship in reactions and it enables precise chemical calculations. Limiting reactant completely consumed first determines total product quantity. Atom economy, percentage of reactant atoms in product, and it indicates process efficiency. Now let's talk about molar chemistry. Here we have gas calculations and Avogadro's laws. Some key principle of gases. Let's talk about gases consist of particles with significant space between them. Avogadro's law is equal volume of gases contains the same number of particles under same conditions. Now let's talk about molar gas volume. So standard condition is room temperature and pressure where the temperature is 25 degrees centigrade or 298 Kelvin and the pressure is 101.3 K Pascal over 1 atmosphere. Molar gas volume. 1 mole of any gas occupies 23 dm cube at standard room temperature and pressure. Now let's talk about some fundamentals of this chapter. Concentration definitions. So what is mass concentration? Mass of solute per cubic decimeter. And what is molar concentrations? Moles of solute per cubic decimeter. Alright, now for acid and base titration. So, how to conduct the process of titration? First, prepare standard alkali solution, then measure precise volume, then use indicator to determine neutralization point, and now you can calculate concentration through chemical reactions. Key titration principles important to learn uses standard solution with known precise concentration, neutralization reactions between acid and base, and then volumes measured accurately using pipette and burette. Now, in the calculation step, first you have to calculate moles in a standard solution. Then you have to use balanced chemical equation to determine moles of reacting substances so that you can calculate unknown concentrations. Some important conversion techniques. Conversion methods. You need to convert between moles and masses. You need to convert between volume and concentrations. And also, you need to learn how to convert solutions of different volumes. Practical considerations, always check units. Use balanced chemical equation. Apply consistent calculation methods. Now, let's talk about mole concept in detail. Definition and significance important to learn. So, mole, a fundamental unit in chemistry representing Avogadro's number of particles. The constant is 6.022 times 10 power 23 mole inverse. Used of quantity, quantify atoms, molecules, or ions in a substance. Now, in calculating molar mass of 1 mole of a substance in grams, calculated by summing atomic masses of elements in a compound. Now we have one calculation, for example, for ethanol, where the formula is C2H5OH. If I want to calculate the molar mass, I will go one by one to each of the atoms inside ethanol. So carbon, I can see 2 and the atomic number is 12. So you will multiply this number of atoms with the atomic number and you will get the carbon 24. Then hydrogen, 5 here and 1 here, so 6. 6 times 1, 1 is the atomic number of hydrogen. 6 times 1 is 6. Then oxygen, I can see only one particle here, so 1 atom times the atomic number is 16. So 1 times 16 gives you 16. Now you add all three of them, 24 plus 6 plus 16, and you will get the molar mass, which is 46, and the unit, very important to write, gram per mole. All right. Now let's talk about gas volume calculations. Standard condition, room temperature and pressure. 1 mole of any gas occupies 24 dm cube space. Important to learn. All right. Next, some calculation techniques. Convert between volume and moles using standard molar volume and use dimensional analysis to solve gas-related problems. Some Greek chemistry principles. There are 12 key principles. Number 1, prevent waste. Number 2, maximize atom economy. Number 3, less hazardous chemicals. Number 4, safer chemicals and products. Number 5, safer solvents and reaction condition. Number 6, increase energy efficiency. Number 7, use renewable feedstocks. Number 8, reduce derivatives. Number 9, use catalyst. And then number 10, design degradable products. Number 11, analyze for pollution control. And number 12 is accident prevention. Now let's talk about industrial process consideration. It maximizes raw material utilization. It is used for renewable energy sources. It minimizes environmental harm. It improves energy efficiency and reduce waste production. Now let's talk about some percentage calculations. Key percentage calculations for which you need to learn the formula percentage yield. What you will do, take actual product mass and then divide it by the theoretical product mass times 100. Then for percentage purity, use pure substance mass divided by total sample mass times 100%. Then for percentage composition, take mass of the element and divide it by total compound mass times 100%. All right. Now, some empirical and molecular formulas, calculation steps determine the mass percentage